Okay, so I'm doing problem 38 in section 5.4. This is what the problem looks like. And what you're going to be using, which I find is the quickest and easiest way, is to use a binomial theorem to simplify this. Binomial theorem is x plus y cubed. So this would come out to distributing the cube to the x, adding 3, and then one less than that, x squared. And then now it's the y's turn. This is 3x, and now it's y squared. It's y cubed. Okay, and since this is what you're simplifying, you see this is the x, and these are the y terms. So then you just apply it to the integral, and it's going to look like this: 1 cubed plus 3, 1, which is the x, squared, which is your y term, plus 3, and this time the x squared is squared as per this right here. And then I'll just continue this on the bottom. Your x squared will be cubed as per this part. Okay, and then your next step, just take the antiderivative of everything, which will give you x plus 3 times 1/3 x cubed, because that's the antiderivative, plus 3 times a fifth x to the fifth, because that turns into the x fifth, plus 1/7 to 7. You just simplify, you see these 3's cancel, and this just moves to the top of this fraction. So that's x plus x cubed. Since those 3's cancel, all you left is with the x cubed, plus 3/5 x to the fifth. And the 1/7, nothing happens to that, so you just bring it on down, and you evaluate this from 0 to 1. And as you can see, just mentally plugging in 0, everything else is going to be 0. So you're really only worried about your 1. So you just plug in your 1, and you're given 1 plus 1 cubed plus 3/5, 1 to the fifth, and then a 7th, 1 to the 7th. This leaves you with 1 plus 1 plus 3/5 plus 1/7. And once you simplify all that, add it, multiply these two bottom terms, you're given 96/35, which is your final answer.